This is a video on triple integrals. The question states, use a triple integral to find the volume of the solid bounded by z equals 5 minus x squared minus y squared and z equals 1. So let's start by sketching a diagram. Z equals 5 minus x squared minus y squared. That's a paraboloid because we have a z equals negative x squared and a z equals negative y squared if x and y are 0. Those are both parabolas. The paraboloid starts at 5 on the top because if x and y are 0, z is 5. And it goes downwards because of these negative signs. So here's my paraboloid. Z equals 1 is a plane parallel to the xy plane, lifted up 1. So here's my plane. We can imagine it being parallel. And it is going to intersect this paraboloid. So let's look at this little man. I have the little man standing up and down, and the little man's feet are at z equals 1, and the little man's head is at z equals 5 minus x squared minus y squared. So that will be my inner limits. For the outer limits, I look at the intersection of the paraboloid and the plane, and then take the shadow of that onto the xy plane. So to find the intersection, I set 5 minus x squared minus y squared equal to 1. And then I move things around, and I get x squared plus y squared equals 4. And that's a circle of radius 2 centered at the origin. So I sketch that in the xy plane because I'm looking at the shadow onto the xy plane. And look at the little man. I put him standing up and down. The little man's feet are at negative the square root of 4 minus x squared. That's the bottom semicircle. And the little man's head is at positive the square root of 4 minus x squared. That's the top semicircle. And those are what happens if I solve for y in this equation, x squared plus y squared equals 4. For the outer limits, I look at the little man and see that the farthest left the little man can go is x equals negative 2. And the farthest right the little man can go is x equals 2. So now I'm ready to write down my integral, or at least set it up. And I get that the volume is equal to the integral. X went from negative 2 to 2, and y goes from negative root 4 minus x squared to positive root 4 minus x squared. And then z goes from 1 to 5 minus x squared minus y squared. And then since I have a volume, I have dz, dy, dx. Now I could integrate this. The integral of dz is just z, and I can plug in 5 minus x squared minus y squared, and then plug in 1 and subtract. And then I can integrate from negative the square root of 4 minus x squared to positive the square root of 4 minus x squared. Then do some trig sub and work this out. But instead, I did it the easy way out because I figure you all know how to integrate by now. And I used a calculator. And what I got is that the volume of the solid bounded by z equals 5 minus x squared minus y squared and z equals 1 is exactly equal to 8 pi. And I'm done with the problem.